Good day, everybody, and welcome to another one of James's videos. Today we will be dealing with our type 4 trigonometric equations, grade 11, and it's an example where we're going to be dealing with factorizing and identities. So we've been given an equation, we've been asked to solve for theta, and we have been given a domain. What does that mean? Remember, when we get given a domain, it means we are actually working specific solutions out for this equation and not a general solution. So we're going to go one step further than that general solution and sub values in for k. So what we're going to look at first, obviously we've got now a sine theta and a cos squared theta. Now remember in the previous videos we were explaining to you guys, okay, cool, if we have sine and cos on both sides, we have to look at the angles if they're the same or not, because that'll determine whether we're using tan method or co-ratio method. But here at the moment it's a sine theta and a cos squared theta, so they're actually two different functions. So we have to rather look at our identities and factorizing techniques for these types of questions. When the squareds come into play, that's kind of the giveaway that we need to start looking at these type of methods. So the first thing that I can see is that I'm dealing with sines and coses, but the one thing that I can't change is the sine, but I can change the cos squared into a sine using my identities. So just a reminder, our Pythagorean identity for trigonometry is sine squared theta plus cos squared theta equals 1. So that means that can be adapted to make certain things the subject. So sine squared theta is equal to 1 minus cos squared theta, and cos squared theta is equal to 1 minus sine squared theta. So I'm looking at that and I'm having a look now at this. This cos squared theta can change. So let's do that. Let's change it into the 1 minus sine squared identity. So 8 sine theta equals 3 1 minus sine squared theta. Notice how I'm putting it in brackets, everybody, because it is turning into a binomial and we still need to times that 3 in. Okay, so what I'll do from here, let's times it in just to get rid of the brackets. 3 minus 3 sine squared theta. Now guys, unfortunately with these type of things and identities, a lot of people ask me, James, when do I know to change it? Well, that kind of comes with practice, and it's a little bit like chess. We need to think 5 steps ahead before actually committing to it. So we need to kind of play it out before we commit to choosing that specific identity, because what I could see here is by changing that cos squared into the 1 minus sine squared, I could see a trinomial type equation forming. So what I'm going to do is I'm going to bring everything over. So I'm going to bring that over, it's going to change to a positive. The 8 sine theta stays on the left, so that stays its same sign. And then I'm going to bring the 3 over, which changed to a negative. Now what I can see here is a trinomial. So what I do also, just a little bit of a hint, if you struggle to see the algebra, the trinomial here, you can always let sine of theta equal k, for example. So what would that do? Then that would create 3k squared plus 8k minus 3. Now that looks in terms of algebra like a trinomial that I can factorize, right? So let's do that. So let's factorize it now. Open bracket, close bracket, open bracket, close bracket equals 0. Let's think of our factors of 3, factors of our first, factors of our lasts. Okay, is there a way for me to get 3 and 8 in the middle? Yes, 3 times 3 is 9, 1 times 1 is 1, and then I can get that by going plus 9 minus 1. So we can say 3k and k, 3 must times by the 3 and it must be a positive, and it must times by the minus 1 to give me the minus k. Awesome, so the factorizing all sorted. Now I can go ahead and say therefore 3k minus 1 equals 0, or k plus 3 equals 0. And let's simplify it even more and make k the subject. So k is going to equal a third, or k is equal to minus 3. At this point in time, guys, we have finished the algebra stage of simplifying this trigonometric equation. And I can now sub the sign back in, because at the end of the day, we're still doing trig. We mustn't forget. Okay, so we're going to sub the sign back in. So sine of theta equals a third, or sine of theta is equal to minus 3. Okay, so first of all, what I can do here, this is definitely going to be a no solution. Why? Let's think about it. Can a sine graph, if we think of the sine graph, it goes to a high point of 1 and a low point of minus 1. So if I had to think about minus 3 down here, does my sine graph ever get to -3? No, it doesn't. So it never exists anything lower than -1, and it doesn't exist anything higher than 1. Okay, so that's why I'm saying that sine of theta can never equal -3, therefore no solution for that part of the equation. However, sine of theta equaling a third, that can definitely work, right? Because a third is somewhere here, and do you see how this line goes through my graph? So we will get answers here that it will be a third. So let's go straight into reference angle. So we go take our calculator, shift sine of a third is equal to 19,47 degrees. And then we draw our mini cast diagram because we're also looking where sine of theta is positive a third. Where's sine positive? First and second quadrant. Fantastic. So we're going to be doing our general solutions in the first and second quadrant for this question. So theta quadrant, 180 minus theta quadrant. So we're going to say our angle that we're solving for is theta, because that's the angle here with the sine. Remember, whatever's next to the trig function, when you work out your reference angle, that is the angle that we're going to be solving for in our general solution. So now we're going to say theta equals our reference angle plus K360. K is an element of integers. Our second quadrant, we're going to say theta equals 180 minus my reference angle plus K360. K is an element of integers. Fantastic. Now, this general solution on the left in the first quadrant is finished, but this one over here, we have to do a little bit of simplifying. So 180 minus my reference angle is 160,53 degrees plus K360. K is an element of integers. Now we can do the fun part. Because we've been given a domain in our question, guys, let's have a look. Our domain, solve for theta, where theta is an element of minus 360 to 360. So let's actually just snip that out here quickly and let's bring it down so that we won't have to always scroll up. Okay, so we know that our domain we're dealing with is going to be between 0 and negative 360 and 360. So let's sub in values quickly. Let's have a look. So if K for the first quadrant equals 0, therefore theta is going to equal 19,47. Going to be an answer? Yes, it is, because it falls in my domain. Fantastic. Let's do 1. 1's going to fall out. Let's do minus 1. So if K equals minus 1, therefore theta is going to equal, so that would be 19.47 minus 360, and that gives me minus 340,53. Does that fall in my domain? Yes, it does. So that is a solution. If I make K minus 2, everybody, it is definitely going to fall out of my domain. We can do a little bit of mental math here. We don't have to figure out the exact answers, but I'm pretty sure with our mental math capabilities, we can see whether it's going to fall in or out of the domain. Let's do this. If K is equal to 0, therefore theta is going to equal 160,53, which is definitely in our domain. Let's do 1. 1 isn't going to work because it's going to be too big. And if we do minus 1, it will also fall into the domain. So we can say 160.53 minus 360, and we're getting a minus 199,47 degrees. And fantastic, guys. So that is our answer for these. There's 4 answers here. So let's see. Theta, always in descending order, everybody. Ascending order. So we always start with our lowest. So 53, we've got minus 199,47. And we've got 19,47 degrees. And we've got 160,53. Now, let me explain something to you guys quickly. I always like representing this on a graph because it's so satisfying for you guys to understand, okay, how do trig equations link with graphing? Everything can be graphed. So we are dealing with the sine theta graph. So if I had to draw this graph, and it's just a little bit of knowledge, you didn't have to do this to finish the question, but I just want to show you guys how it works. So we've got 90, 180, 270, 360. 90, 180, 270, 360. Okay, let's just draw it out like that. Very rough, please excuse the neatness. And then we've got that, and we've got a 1, and we've got a minus 1. So now if I had to draw a sine graph here, guys, Also very good to know your parent functions. I know we can use our calculators to work this stuff out, but it's so vital for graph interpretation if we know the basics of how our graphs look. Because the calculator can't help you with interpretation. It can definitely help you with drawing them, but it can't help you with the interpretation, okay? So having a general idea of what our shape looks like. Now, let's have a look. We've got a third, which is going to be somewhere here. So if I had to draw a dotted line going like this across, how many times does that line cut this graph? It cuts it 4 times. 1, 2, 3, 4. How many answers did we get here? 1, 2, 3, 4. And I'm pretty sure these answers are going to link. So the first one here is going to be the minus 340, 53. This one over here is the minus 199, 47. It looks also more or less correct according to my axes, doesn't it? Minus 360, minus 340 is just before minus 360. And this one's just after minus 180. This one over here is going to be our small one. So this one was the 19,47. And this one over here was the 160,53. So do you see how we can always relate our results of our equations to a graph? Okay. And that is, obviously you guys would have all stopped here. I mean, this is your final answer. I was just going one step further and representing it on a graph for you so that you can understand it and understand what exactly we're doing. Okay, guys. So another thing, just bringing you back to this, if you could get from here to here without doing the yellow, by all means you can. I'm not saying the yellow you must do. I just say that if people struggle to see the factorizing or the trinomial, it's a lot easier to look at it when it's algebra rather than trig functions, okay? But if you have that site where you can see the trinomial with the trig functions in it, by all means, please go for it. Okay, I hope you enjoyed this video. We're going to do another hard one after this. And then, if you like the videos, please subscribe. Click the subscribe button at the bottom. All these notes are also available on the James book, which is for sale. So if you are keen, please make contact with us via the website or drop us a comment in the comment section and we'll get in contact with you. Awesome. Thanks, guys.